Everyone, let's look at this limit problem here. We are going to use L'Hopital's rule to evaluate this limit. Okay, so how do we do this? First, we need to verify that it's actually an indeterminate form and it's in the form of infinity over infinity so that we can apply L'Hopital's rule. Okay, so let's get started on this problem. First, we are going to check the form by considering what happens to the numerator and the denominator when x is approaching infinity. So as you can see here, when we put the infinity here, this is the informal work, but then actually it will tell us what's going on. So as you can see, 3 to the infinity is actually infinity, and then we subtract the 2, that's still infinity. So as you can see here, the top is infinity. And then what about the bottom? The bottom is actually the same situation. We have 4 to the infinity, which is infinity, minus 2, then we also get infinity. Okay, so now we can apply L'Hopital's rule here. Okay, so that means we are going to take the derivative of the numerator and the denominator separately. Okay, so what is the derivative of the numerator? We have 3 to the x here. The derivative of 3 to the x is actually 3 to the x, and then times ln of 3. And then what about the minus 2? There was when we differentiate a constant, we are going to get 0. So there is nothing that we need to write here. So the derivative of the numerator would be just 3 to the x and then times ln of 3. Now, what about the bottom? The bottom, we also need to differentiate the bottom. Okay, so the bottom would give you, what is that? The derivative of 4 to the x, which is 4 to the x. And then times ln of 4. Okay, so again, the minus 2 will disappear, right, when we differentiate that. And yeah, so you may say this is still infinity over infinity when you let x approach infinity, right? And so you want to apply L'Hopital's rule again, but if you do that, then you are going to get ln 3 to the second power and then ln 4 to the second power, and then those exponential functions will never disappear. So you're not going to get anywhere. You're always going to be getting infinity over infinity. So that's not good, right? So we don't want to apply L'Hopital's rule again. We actually need to think about what's going on here. So ln 3 over ln 4, that's really just a constant, so we can put it in the front. And all we need to worry about is 3 to the x and then 4 to the x. See that because they have the same exponent, we can actually put them together as a fraction. So let's do that. So in our next step, we are going to, so let's just put the ln of 3 over ln of 4 in the front. Okay, and then times. Now this one is 3 to the x and 4 to the x, and for that we are going to write it as 3 over 4 to the x. And so now let's look at this exponential function here. Now, because the base is less than 1, right? It's between 0 and 1. So if you look at the graph of this exponential function, it actually looks like this. It has the shape. We are not going to graph the details, but if you just think about graphing the 3 over 4 quantity raised to the x power, then we are actually going to get a graph that looks like that. Okay, so see that this is actually approaching the graph on the right side. When x is approaching infinity, that's actually approaching 0 from the right side. Actually, it's it's approaching 0 from the right side. It's above 0. It's above the x-axis. Okay, so what happens? Then that really means that this thing here, this 3 over 4 to the x, is actually approaching 0, and it's positive, right? And so what's going on here? We have this quantity that's approaching a really small number, and we have ln of 3 over ln of 4 times that small number, and so the whole thing is actually approaching 0. So in this case, the answer would just be 0. It's really because, right? So this is because 3 over 4 to the x is approaching 0 as x approaching infinity. Yeah, so that's our answer for this limit problem here. And yeah, so just one thing just to note here is that after we apply the first time of L'Hopital's rule, those constant terms will disappear. And if after they disappear, then we shouldn't be applying L'Hopital's rule again, because we're not going to get anywhere if we do that. So the strategy for dealing with this kind of limit problems when we are using L'Hopital's rules is that we just need to make sure that the exponential functions are the only functions that will stay here. And yes, they can be multiplied to some constants, but we just don't want any extra terms because they're not in charge for this for the behavior when x is getting really large. Okay, so that's it for this problem. Thank you for watching. See you next time.